Hey guys, we're going to get started with part 2 of chapter 16. Hopefully you've had time to watch the little short 25-minute part 1. I felt it was necessary to break this chapter down into 2 because of this platform format. I know it's hard to stay focused on such a long lecture. So picking up where we left off, I'm going to go ahead and share the screen again and get to our PowerPoint. Let me get there, and we will go from current slide. Okay, so starting on page 252, I believe that's correct in your book. Yes, on page 252, it's got the header called the 15% rule, and what that actually is going to be talking about is how do we adjust for the creation of more x-rays. As we increase our KVP from part 1, we discussed that not only is the penetrability of the beam increasing, but actually your quantity of x-rays are going up also. And so in other words, you're creating more penetrability as you increase your KVP, and you're also increasing the number or the quantity of x-rays. So we have to do some type of balance so that we can adjust our exposure. So when we're increasing our KVP, we're not using too many x-rays because increasing KVP is actually increasing quantity of x-rays. So the 15% rule applies here, and it says on page 252 under the header, the 15% rule, it says the relationship between KVP and actual exposure at an image receptor is not linear, but an exponential one. Linear meaning not directly related. Like Dr. Haynes said, mass is directly proportional to the number of x-rays. So as you increase your mass, you're increasing the number of x-rays proportionally. When we are increasing our KVP, the number of x-rays that's being generated is exponentially, not linear. It's not directly related, but exponentially created. And that's a little hard concept to understand, and it does give you some more clarification on the page as you do your reading. But it talks about the intensity of the primary beam increases approximately by the square of the KVP. However, exposure at the image receptor also depends upon penetration of the beam through the body. Now let me read those 2 bullets over again. The intensity of the primary beam being the beam coming directly from the tube, increases approximately by the square of the used KVP. However, exposure at the image receptor, so this is actually going through the patient, also depends upon penetration of the beam through the body part. So you're talking about 2 different parts of the beam. You're talking about the primary beam, and you're also talking about the amount of radiation reaching the image receptor after it has transmitted through the patient. When both effects are taken into account, we find that actually exposure of the remnant beam, that remaining left over to expose the image plate, goes up by about a factor to the 5th power of the KVP. That's a huge, huge increase. But all that is explained in your book. There's a lot of 4th power, 5th power. Honestly, I don't want you to be too frustrated with that. Read it. Some of you will get that instantly. Some of you don't. I find it's an extremely hard read for your level of students. But I do want you to understand that there are 2 types of increases in x-rays, because as we increase our KVP, the actual primary beam increases. The number of x-rays actually increases in the primary beam, and it also increases in the remnant beam. Think about this. in an exposure where the majority of your x-rays attenuated and got absorbed at a certain kVp, say 50, now that we're going to increase it to 70, those that got partially absorbed at 50 are now going to push through. So that's where that exponentially more x-rays are coming out of the patient. That's why it's an exponential increase in the number of x-rays, because those that were relatively or really actually stopped and absorbed, they will no longer be absorbed, but they will transmit through along with the actual other ones that are being created because of the increased Brimstrong interactions in the tube. This all ties together, guys. It's to me, it just seemed like so much material to cover in one lecture. So that's why I'm trying to break it down for you in these smaller segments. So it says that there's a much simpler way of understanding this, and it's called a formula. It's a simpler formula states that for every 15% change in kVp, exposure to the IR changes by a factor of 2. Now, what is a factor of 2? A factor of 2 can be double, 2 times means double, or by a factor of 1/2. 1/2 is a factor of 2. So we're either going to double or we're going to take a half of it. And that's going to apply here in just a second. I just want you to slow down right there, and it just says, it talks about a simpler rule of thumb. It's on page 253. It says a simpler rule of thumb conventionally used by radiographers is called the 15% rule. It states that a 15% change in kVp will change the exposure of the image receptor to the remnant beam by a factor of 2. Now, whether or not we're increasing or decreasing kVp depends on whether or not we're going to double or half our exposure. I know this gets confusing, but it's really easy once we get into the math part of it. So on page 253, it says to maintain, that's the word there, maintain exposure at the image receptor for every 15% change in kVp, whether it's going to be an increase or a decrease in kVp by 15%, we will adjust the mass by a factor of 2. So if we're going to increase our kVp, we're going to have to reduce our mass by 1/2. Notice those are going in opposite directions. As kVp goes up, your mass is going to go down to 1/2. If your kVp is going to go down, we're going to double the number of mass. So we're going to multiply mass by a factor of 2, or we're going to divide the mass by 1/2, depending on which way we go with the kVp. So it says most accurately, this should be done in steps. That is, recalculate 15% for each step. To increase kVp from 80 to 110 for a solid column barium study, you start with your original exposure, 80 kVp at 20. So what we're going to start doing, we're going to start changing our kVp. We want to get it up. So we're going up in kVp. We're going from 80, we want to get it to 110. So the first one, we're going to do it in a step. We're going to take 15% of 80. We're going to add that 15%, which is 12, to our original kVp of 80. And now we have a new kVp of 92. That's our first 15% increase. We're now at 92. But since we've gone up in our kVp by 15%, we're going to take the original mass of 20 and we're going to halfen it. So now we're at 10. The next thing we're going to do, the next step, we're going to take the new kVp, which is 92. We're going to take 15% of 92, which is 14. We're going to add it to our 92, which gives us 106 kVp. So we've gone up again in our kVp, getting closer to our required 110. So we're going to step down our mass one more time and divide it by half again. So we're now at 10, we're going to go down to 5. So now our technique is 106 at 5. And I'm going to stop right there because a further increase of 15% would take you over the 110 that you're looking for. So just a minor adjustment, a slight further increase in KVP. If you think about you're at 106, you're only needing 4 more KVP. That doesn't justify doubling or halving your mass, so they're just going to reduce it by 1. But if you get that process of what we're doing to one side, if we're increasing our KVP, we're going to be doing the same thing, but in the opposite direction to our mass. And if we're going down, we're going to half it. If we're going to go up, we're going to take we're going to double it. It gets easier. Don't get frustrated. Again, this is well explained step by step on page 253. This exact same example is in the second column, so I want you to go back and read over that. But just look what we've done. We've gone from 80, adding 15%. 15% was 12. We're now at 92. We take our original mass and we half it. We take our new KVP, take 15% of it, 14. We add it to the new KVP of 92. We have 106. We take our new mass, which is 10, and we're going to half it again. And we're going to stop there because at 106, you're close enough to 110 to get your 110 KVP is what you were after. So let's look at something else, doing the mental math. And I can tell you right now, this is not something that we're going to worry about when we get to the second bullet here, but it says to find 15%, take 10% of the starting amount, then half that much again. To adjust to KVP in portions, we will not be doing that. We will not be doing halfway to an equivalent doubling, 1/3 way to the equivalent. We won't be doing that. But it says the following pairs of techniques are all equivalent. 60 mass at 40 KVP. 30 mass at 46 KVP. Where did they get to 46 from? Okay, they got to 46 because it says take 10% of your KVP, which is 4, then take a half of that, which is 2. So 4 plus 2 is 6. So your new KVP is 46, and we went up in our KVP, so we reduce our mass to 30. So we were at 60 at 40, 60 mass at 40. We did the 15% rule, and we got 46. So now we have 36. 30. Tongue-tied here, apologize. Okay, so the next one is 25 mass at 92 KVP. And we're wanting our KVPs going from 92 to 80, so it's going down. So we're going to have to double our mass. So our mass was 25. It's going to be at 50. So we're going to take 92%. Half of 92 is 9, and half of 9 is 4. So 9 and 4, 9, 10, 11, 12, 13, about 13. So we want to add, say, 12 or 13 to the 80, which gives you the 92. Does everyone see how this is being done? So we've got 15 mass at 110 KVP. We look and we see, okay, well, our KVP has gone up one step. It's 110 to 126. So what do we need to do to our original mass? We need to look, we went up, so we take our mass of 15 and we half it, because we're going to do the opposite of what we've done to our KVP. All right, to avoid confusion, think in proportion rather than percentages of desired changes. The opposite of increasing to 3/2 is to decrease to 2/3. That's the same concept of saying if we're going to half or double, it's a multiple of 2. All right, let's do this one here. This is kind of an easy one. I'm going to let you think about it for just a second, because it's asking what results in 1/4 the original exposure, and you're at 80. Okay, well, what is 1/4 we're looking for? So 1/4 is actually half of a half. So what we're going to do, we're going to step down KVP by 15% first. So we're going to take our 15%, and it's going to come out to be 12. So 80 minus 12 gives you 68. Do it one more time because we're wanting a fourth. So that's 2 halves, right? 2 halves equal 1/4. So now we're going to step it down again. We're at 68. 15% of that is roughly 10. So we're going to take 10 from the 68, and your answer should come out to be 58. Again, I'm going to back up and show you that one more time. Starting at 80 kVp, what new kVp would result in 1/4 the original exposure? The original exposure is 80, and we're wanting 1/4 of it. To get to 1/4, you're going to step it down twice. You're going to half it, then half it again. So you take 15% of the 80, which gives you 12. You subtract 12 from 80, which gives you 68. That's your new kVp. You've stepped it down one time. Now, 15% of 68 is going to give you 10. So 10 from 68 is going to give you 58. That would result in 1/4 of the original exposure of 80 equals 58. Okay, does everybody understand that? Let me make sure I have this one worked out for us so I can get to it quickly. Okay, so this in here, it says starting at 400 MA at 0.05 seconds and 90 kVp, what new kVp would maintain equal exposures using 300 at 0.0167 seconds? First thing you got to do, and you know this from what Dr. Haynes talked about, is you have your MA and your time, you have your new and your old, your 400 at 0.05, your 300 at 0.0167. Go ahead and multiply those together. So we have 400 times 0.05. That's going to give you 20 mass at 90 kVp. And we want to get our mass down to 300. So we're trying to get our 300 to our 1.07, which is going to give us, I believe it's going to turn out to be 5, if I'm not mistaken. Let me do the math for you real quick. 300 times 0.0167. So we're looking for 5. So right now we're currently at 20 mass at 90 kVp. So we're going to step down your 90 kVp because we're trying to get down to the 5 mass, which is 300 MA at 0.016 seconds. Okay, so we're trying to get from 20 mass to 5 mass. How many steps is that going to take? We're going to half it. So 20 half to 10 is 1 step. 10 half to 5 is 2 steps. So we have to step this down, our kVp, twice. So from at 90 equals 20 mass, that's what we're starting with. So at 15% of 90 is rounded up to 14. So we're going to add that because we're going down in our mass. We're going from 20, trying to get down to 5. So we're going in the downward direction. So we have to go up in our kVp. We're going to add 15% of 90, which is 14, which is good to give you 104. So now we have 104 equals 10 mass because we brought our 20 mass down 1 step. Our next one, we're going to take 15% of our new kVp of 104. Take the 15% of 104, and that's going to be roughly 16. So we're going to add 104 plus 16, which will give us 120. And now we're able to take our new mass of 10, and we're going to drop it down to 5 mass. So we've just reduced this down from 20 mass down to 5 mass. We had 90 kVp at 20. Now we have 120 kVp at 5 mass. And guys, those two will give you the same output on the machine. That's what you need to start letting sink in. These two numbers, these two situations here, the 400 MA at 0.05 at 90 and 300 MA at 0.0167 seconds, 5 mass. So you got 20 mass at 90, and now you have 5 mass at 120, will give you the same exposure to the IR. That's called the 15% rule. Okay, so there's your answer, 120. Okay, I'm going to do one more and then I want to stop because I know it's a lot for you. Okay, so now we're starting out at 300 at 0.033 at 120. We're going to be looking for a change in KVP that would maintain equal exposure using 400 at 0.1, which is going to be 40 mass. So right now we're at 9.9 mass. I'm going to round that up. We're at 10 mass and we want to get it to 40. So we're going from 10 mass, we want to go up in our mass. So if we're going up in our mass, that means we need to start going down in our KVP. Because remember, we're currently at 10 mass, that's 300 times 0.033 equals 9.9, ballpark it up to 10 mass. 10 mass at 120, they want us to get down to 40. I'm sorry, get up to 40. Okay, so now we're going to take our 120. 15% of 120 is 18. So we're going to subtract 18 from our 120 for our first step, which will give us 102 KVP. And now we had 10 mass. Now we're going to double it. That's our first step. So now we're at 102 KVP equal 20 mass. We got to step it down one more time because we were trying to get to 40, which is 400 MA at 1 second. So we take 102, take 15% of that, which is around 15. So now we're going to subtract the 15 from the 102. It's going to give us 87. So we have 87 KVP at 40 mass. There's your answer. And it says, please do the exercises in 16.1 in the textbook. Please don't. Those are way more complicated than what I need you to understand. I need you to understand the 15% rule helps us manipulate our KVP. As we increase and decrease our KVP, we can actually do the opposite of mass. And we'll talk about that in our next set, our next little video, where we talk about the advantages of the 15% rule and how this actually helps to reduce patient exposure. Again, if you have any questions about this, please let me know. This is something I will talk about tomorrow again, but this is the 15% rule. Whatever you do on one side, you do the opposite direction on the other. For every incremental change in KVP by 15%, you're either going to double or half the mass, depending on which direction you're going with the KVP. That's part 2. Again, I'm going to try to do another small session this afternoon to help you understand how this relates to reduced patient exposure. Thank you, guys.